All right. So an important math model here we are introducing is matplotlib library. Okay, we are going to import this model. All right, just like we import NumPy. Okay, then there is a image read command. So basically you do plot image read and then type the name of the file. We do have the file in Canvas also. Okay, so let's see what happened. All right, nothing happened, right? So we basically read the image and then we already have the file which is understandable for a computer. We call it G. So firstly, let's look at the type of G. It really store our image as a NumPy array. And then if we look at the shape of G, so it gives us 3 dimensions. So basically, strictly speaking, it's not a matrix. Now let's take the first 2 numbers. Basically, we are doing a 720 and 565 matrix. Okay, there's something wrong here with the numbers. So let me correct that. So 720 rows and 565 columns. Okay, and the 3 RGB channels. So basically, you can understand we have a large matrix. Okay, where each entry is a vector. It remember the value of the red, the green, and the blue. Okay, so that's why there is an extra 3 here. You have extra 3 dimension in each of the entry. Okay, so now let's say what's going on with the actual image. So let's plot the image. Okay. All right, great. So this is a Gauss image taken from Wikipedia. So the computer really understand it as a matrix. Okay, with 3 RGB values. Now let's further play with this image. Okay, we can make it grayscale. So now it's a color image. We have 3 RGB value. So the way we make it a grayscale is actually by taking the mean of all the RGB values. Okay, for example, we have a vector of 111. Okay, we just take the mean. And then let me show you what to do. Okay, this command means we take the mean of the RGB value, and then we only consider the 2-dimensional matrix, which means a huge matrix. Okay, so now I have a reduced dimension array from 3D to 2D. Now we actually have a matrix. Okay, so now the shape of the array is 720 by 565. So it's a huge matrix, right? Okay, so this is about the MATLAB command. But now let's plot the image. All right, so now you can see it's a grayscale. Okay, so the rest thing is about the grayscale image. So now we faithfully have a matrix here. Okay, so now you can print the first 5 rows and columns. So basically you can think I take the upper left corner from a really huge matrix. Okay, and then if you read the original matrix, you still have a large matrix, but that's like upper left corner here. Okay, then we can sort of reshape it into a vector. So this is the number you do by multiplying the 2 dimensions. Okay, so now the last thing I will leave you guys if you want to play with that. So I'm going to do some statistics of my normalized grayscale. So firstly, I take the mean of the grayscale. I take the maximum grayscale as 1, and then everything else I divided by the maximum grayscale. Okay, then we can plot a histogram. Okay, so let's wait a while. All right, so this is like taking the statistics of the grayscale of your spots. So we have most spots having low grayscales and very few spots having very heavy grayscales. So basically, we can do some more analysis for our image. Okay, so basically, this is some ABCs for the image processing using Python. Okay, if you remember our website, the very first page, we are playing with the Einstein's photo, right? So we try to make a clear photo, somehow a mosaic style, okay, by averaging some of the submatrices to make it less clear. So that's basically like reducing the dimension of your matrix. Okay, maybe you can try that in your spare time. That's not in the Jupyter Note, but that's probably not very hard. Okay, so I think I will say this much about this image processing, and thank you for being here watching this. All right, we will see everybody on Friday. Okay.